Page 510 is a continuation from what was done in page 509. If you have not completed the observation in 509, go back. Specifically because this part, that's all you're going to see. How do you know the triangles in your sketch are similar? Well, the angles created by the person and the flagpole to the ground are right angles. And from, thank you, Mr. Euclid, from the Greek lands thousands of years ago, all right angles are congruent. Also, the reflection, so that would be like the bounce of what your eye sees looking in the mirror to the top of the flagpole, creates equivalent angles. I lied. You're going to see this image over and over. So those two angles are the same. These two angles are the same. And so therefore, the reflection creates congruent angles. And by angle-angle similarity, the triangles are actually similar. So I highlighted in the previous sketch the sides of the flagpole and the person green, the ground level orange, and then this line of sight, maybe representing light, highlighted that yellow, which is there. We're going to talk about it. But if I make a fraction of the sides, I could put AB, because that's the person's height, over ED, because that's the flagpole height. So that's what I've done. In fact, I'm going to make sure that I bring color back into this fraction. This is the green fraction because it was made with the green sides. Now I'm going to go back to the image over here again. I'm going to use orange. So AB is green and AC is orange. And I picked AC because I mentioned AB as the first. So you got to stay consistent. If you're picking from this triangle first, and that's going to become the top of the fraction, then the bottom fraction that matches it will come from the other triangle, and you have to stay consistent. If you switched it and you picked this triangle first and mentioned ED first, then that would be the top of the fraction and the other side would be on the bottom. It would always be the same, consistently applied. So this fraction is going to have AC over DC. And those are orange because they were the orange sides of their triangles. Last of all, not important for us to know right now, but it could be a useful way to calculate in the future. Maybe there's some reason for you to know the length of that line. It could be like, you know, seen those really, really tall radio towers? We have some around here as well, like out towards, you know, the west part of the town. There are these things called guy wires that help control the pole, the flight, so that the radio tower doesn't fall over and kill people. So therefore, we need to know how long those lines are sometimes, and this would be like the fraction that we could use to come up with that information. BC over EC. Let me check that again just to make sure. Yeah, EC and BC. There they are. Those also are going to be highlighted yellow because they came from the yellow highlighted lines. Now, if you go do this, which you should, this should be actually part of a day's lesson where we're going to go outside. So if you haven't seen that happen yet, know that we are going to go outside and do this measurement together. When you're done with that, you all should have relatively close answers. Mind you, they should not be exactly equal because if you're not accurately measuring your eye height to the ground, and then you magically come up with exactly the same answer, you cheated. So you should be able to go and do this for yourself, do this with your measurements, and then come up with a relatively close answer because you're human. And that's one way that I know that you didn't do your own work for yourself. You should have just different enough answers because you didn't accurately, honestly, you tried, thank you so much, measure your eye height. When you did this measurement, you might not have even stood perfectly 90 right here. But if you could, like a robot, stand perfectly 90 to the ground and not like have any lean to your angle that you're creating, yeah, then your answers are trying to eliminate bias or eliminate chances where, oh, possible sources of error could be found. Honestly, though, don't copy this part. Think for yourself about where your error came from or where your partner's error came from. Like, usually it's in the measurement of things, but, you know, think about that. What could be reasons that we don't all have exactly the same answer? Because if you do, I know you did it wrong. Switch places with your partner, identify the second object. So at the end of this lesson, we should be outside measuring the flagpole, measuring the heights of our stadium lights, measuring the top of a building, things that we can't measure directly, and therefore we need indirect measurement to do it. So go and explore, have fun, of course, with teacher approval, with me leading the way so that you are safe while you do it. Thanks for watching this episode. This has been page 509. No, it's been page 510. Next up is page 511, and I'll see you in the next episode.